Understanding Oracle Database's network architecture is crucial for managing and optimizing your database. A well-configured network ensures smooth communication between clients and the database server, leading to efficient data retrieval and manipulation. This essay will delve into the intricacies of Oracle's network setup, focusing on listener configuration and session management. By grasping these concepts, you can enhance your database's performance and ensure reliable connectivity. Oracle Database relies on a robust network infrastructure to handle client requests. This architecture involves various components working together seamlessly. These components include clients, the database server, listeners, and Oracle Net Services. Each element plays a critical role in establishing and maintaining connections, enabling users to access and interact with the database efficiently. A deep understanding of these components is essential for database administrators and developers. It allows them to troubleshoot connectivity issues, optimize performance, and ensure secure access to the database. This essay will guide you through the core concepts of Oracle's network architecture, providing a clear and concise explanation of each component's function and significance. By the end of this essay, you'll have a solid understanding of Oracle's network architecture, empowering you to configure and manage your database effectively. This knowledge will prove invaluable in maximizing your database's potential and ensuring a seamless user experience. Oracle Database's network architecture facilitates communication between clients and the database server. Clients can be any application or user attempting to access the database. The database server hosts the Oracle Database instance, managing data storage and retrieval. Oracle Net Services provides a communication layer, enabling clients and the server to interact across a network. Listeners play a critical role in this architecture by acting as intermediaries between clients and the database server. When a client initiates a connection request, it first contacts the listener. The listener then redirects the request to the appropriate database instance based on the connection information provided. This process ensures that client requests are directed to the correct database server, even in complex environments with multiple databases. Oracle Net Services utilizes various protocols, including TCP/IP, to facilitate communication. It handles connection establishment, data transfer, and security features. Understanding Oracle Net Services is crucial for troubleshooting network-related issues and optimizing communication between clients and the server. By grasping the interplay between clients, the database server, listeners, and Oracle Net Services, you gain a comprehensive understanding of Oracle's network architecture. This knowledge provides a solid foundation for configuring and managing your database's network setup, ensuring efficient and reliable connectivity. The listener is a crucial component of Oracle's network architecture, acting as the initial point of contact for clients attempting to connect to the database server. Think of the listener as a receptionist who directs incoming calls to the appropriate department. When a client requests a connection, it contacts the listener, providing information about the desired database service. The listener then examines this information, including the requested service name and network protocol, to determine the appropriate database instance to handle the connection. Once identified, the listener establishes a connection between the client and the corresponding database server. This process ensures that clients are connected to the correct database instance, even in environments with multiple databases running on the same server. The listener is configured through a file called listener.ora, which defines various parameters including the listening port, communication protocols, and database services handled by the listener. Understanding listener configuration is essential for managing database connectivity and ensuring that clients can access the database without issues. In essence, the listener acts as the gateway to your Oracle database, managing incoming connection requests and directing them to the appropriate database instance. By understanding its role and configuration, you can ensure smooth and efficient database access for all clients. Configuring the listener is a crucial step in setting up your Oracle database's network environment. The listener's configuration file, listener.ora, defines how the listener operates and handles incoming connection requests. This file contains parameters that specify the listener's listening port, communication protocols, and the database services it manages. One key aspect of listener configuration is defining the listening port. This port is the network address on which the listener waits for incoming connection requests from clients. The default listening port for Oracle listeners is 1521, but you can customize this port based on your network requirements. Specifying the correct listening port is essential for clients to connect to the database successfully. Another critical configuration element is defining the database services handled by the listener. Each database service represents a specific database instance that clients can connect to. For each service, you need to specify the service name, the database instance it connects to, and the network protocol used for communication. Properly defining these services ensures that the listener can direct client requests to the correct database instance. Understanding the listener configuration parameters and their implications is essential for managing database connectivity. By customizing the listener.ora file, you can tailor the listener's behavior to meet your specific network requirements and ensure seamless client access to your Oracle database. Section 5. Session Management. Connecting the dots. Once the listener establishes a connection between a client and the database server, a session is created. A session represents an individual connection between a client and the database, allowing the client to interact with the database and perform operations. Each session has a unique identifier and maintains its own set of resources, ensuring that multiple clients can access the database concurrently without interfering with each other. Session management involves handling the creation, maintenance, and termination of these client database connections. When a client initiates a connection request, the listener allocates resources for a new session and establishes the connection with the database server. This process involves authenticating the client, verifying its credentials, and assigning the session a unique identifier. Throughout the session's lifespan, the database server manages the resources allocated to the session, including memory, processes, and locks. These resources ensure that the client can execute queries, manipulate data, and perform other database operations efficiently. The server also monitors the session's activity, tracking its resource usage and ensuring that it adheres to defined limits. Efficient session management is crucial for maintaining database performance and stability. By properly managing sessions, the server can optimize resource allocation, prevent resource contention, and ensure that all clients have fair access to the database. Understanding session management principles is crucial for database administrators to monitor and control client connections, maximizing database efficiency and responsiveness. Section 6. Session Creation and Termination. Session creation is triggered by a client's connection request. The listener receives the request, authenticates the client, and allocates resources for the new session. The listener then establishes the connection with the appropriate database instance, assigning a unique session identifier. This identifier distinguishes the session from other active connections, enabling the database server to manage each session independently. During session creation, the database server assigns memory, processes, and other resources to the session based on the client's requirements and the database configuration. These resources enable the client to execute queries, manipulate data, and interact with the database effectively. The server also initializes session-specific parameters, such as language settings and date formats, based on the client's preferences. Session termination can occur in several ways. A client can explicitly disconnect from the database, signaling the end of the session. Alternatively, the database server can terminate a session if the client remains inactive for an extended period or if the session violates resource limits. Upon session termination, the server releases all resources allocated to the session, making them available for other clients or processes. Proper session creation and termination are essential for efficient resource management and optimal database performance. By understanding these processes, database administrators can ensure that client connections are established and terminated smoothly, maximizing resource utilization and maintaining database stability. Section 7. The importance of a well-tuned network. A well-tuned network is crucial for optimal Oracle database performance. Network latency, bandwidth limitations, and inefficient communication protocols can significantly impact database responsiveness and overall efficiency. By optimizing network settings, you can minimize these bottlenecks and ensure smooth communication between clients and the database server. One aspect of network tuning involves minimizing latency. Latency refers to the time it takes for data to travel between the client and the server. High latency can lead to slow response times, making database operations sluggish. By optimizing network routes, reducing network congestion, and using efficient network protocols, you can reduce latency and improve database responsiveness. Another critical aspect is ensuring sufficient bandwidth. Bandwidth refers to the amount of data that can be transmitted over the network per unit of time. Insufficient bandwidth can lead to data transfer bottlenecks, slowing down database operations that involve large data volumes. By upgrading network infrastructure, prioritizing database traffic, and optimizing data compression techniques, you can ensure adequate bandwidth for efficient database communication. Investing time and effort in tuning your network infrastructure is essential for maximizing Oracle database performance. By minimizing latency, ensuring sufficient bandwidth, and optimizing communication protocols, you can create a robust and efficient network environment that supports seamless database access and optimal performance. Section 8. Real-world applications and implications. Understanding Oracle Database's network architecture has significant real-world applications and implications. In businesses that rely heavily on Oracle databases, a well-configured network is essential for ensuring smooth operations, efficient data processing, and reliable access to critical information. For example, in financial institutions, where high-volume transactions are commonplace, a robust network setup is vital for processing transactions quickly and accurately. In e-commerce platforms, where thousands of users access the database concurrently, efficient session management is crucial for maintaining website performance and preventing slowdowns. By properly configuring the listener and optimizing session resource allocation, these platforms can handle a large number of user connections without compromising performance. Furthermore, in healthcare organizations, where patient data is highly sensitive, a secure network configuration is paramount. By implementing strong authentication mechanisms and encryption protocols within the Oracle Net Services framework, these organizations can safeguard patient information and ensure data privacy. Understanding and effectively managing Oracle Database's network architecture is not merely a technical matter. It has direct implications for business operations, user experience, and data security. By prioritizing network optimization and security, organizations can leverage the full potential of their Oracle databases and ensure reliable and efficient data management. Section 9. Basic Listener Configuration Example. To illustrate a basic listener configuration, let's consider a simple scenario with a single database instance named ORCL. The following example demonstrates a basic listener.ora file configuration for this instance. Hash listener, ORA network configuration file hash. This file defines the listener for the ORCL database instance. Listener =, description _list =, description =, address =, protocol =, TCP, host =, your host name, port =, 1521, SID _list, _listener =, SID _list SID _desk global _DB name =, Oracle _home =/u01/app /oracle/product/12 2 0/dbpom _1 SID _name =, In this example, the listener is configured to listen on port 1521 of the host your host name. The SID _list _listener section defines a single database service named ORCL. This service is associated with the ORCL database instance located in the specified Oracle _home directory. Clients connecting to the ORCL service will be directed to this database instance. This basic configuration demonstrates the fundamental elements of a listener configuration file. It highlights the key parameters involved in defining the listener's listening address and the database services it manages. By understanding this basic example, you can gain a foundational understanding of listener configuration and its role in facilitating client connections to your Oracle database. Section 10. Conclusion. Mastering Oracle Database's network architecture is essential for any database administrator or developer. By understanding the roles of clients, the database server, listeners, and Oracle Net Services, you can effectively configure and manage your database's network environment. A well-tuned network with a properly configured listener and efficient session management is crucial for maximizing database performance and ensuring smooth client connectivity. This essay has provided a comprehensive overview of Oracle's network architecture, delving into listener configuration, session management, and the impact of network settings on database efficiency. By applying the concepts discussed in this essay, you can optimize your database's network setup, ensuring reliable connectivity, efficient resource utilization, and optimal performance for all clients. Understanding Oracle's network architecture is not merely a technical exercise, it has real-world implications for businesses and organizations that rely on Oracle databases. By mastering these concepts, you can ensure the smooth operation of your databases, enhance user experience, and safeguard valuable data. Investing time and effort in understanding and optimizing your database's network architecture is a worthwhile endeavor that will pay dividends in the long run.